Welcome back, this is Professor Xiaoma. In this video, I will demonstrate and explain a specific hands-on problem. Now keep in mind that in demonstrating the hands-on problem, I will use an example dataset which is default 1. When you do the homework, the dataset is different, so make sure that you adapt the code to work with the homework. In the video, I assume that whatever Python package that we will be using, you have already installed them. If you realize that you haven't installed a specific package and you need to install it in the middle of the video, simply pause the video and go ahead and install it. Install the Python package by following the tutorials that I uploaded. Now let's get started. For this demo, I'm still using the default 1 dataset as is used in many of the other homework videos. To make a column transformer, which also includes a scalar, either the z-scalar or the min-max scalar, and also includes an encoder such as a one-hot encoder, you will need these packages. For this demonstration, I'm using the xtrain and xtest sets as a result of another demonstration video for homework assistance, which splitted the x dataset into the xtrain and xtest set. So one-hot encoder is the first component of the column transformer which I'm going to make. Now the one-hot encoder transforms a categorical variable into a group of flag variables. And in the process of converting to the flag variables, you will also discard one of the labels of each of the categorical variable. By default, you can discard the first label. And here is the code. I combine the two steps in one cell. The first step is to define an encoder. Here, because it's a one-hot encoder, I'm using a one-hot encoder, I specify the option to drop the first label. And the second step is to prepare the column list for one-hot encoder. In the default _1 dataset, there are 3 categorical input variables: gender, education, and marital status. And let's run this. Now, running this doesn't mean that the encoding has finished. I just have finished the 2 elements that is to be used inside the column transformer. And here are to make the min-max scalar. I also combined the 2 steps in one cell. Created the scalar object by using the min-max scalar, which conducts the range or min-max normalization. And then I define a column list to include all the columns that I want to apply the min-max normalization. Now here I use the trick to drop the columns that I don't want from the xtrain dataset, and the remaining columns will be the ones that I would like to apply the range standardization. And I dropped those columns that are already included in the one-hot column list, which definitely will not need to apply the min-max normalization. Let's run this. It's always a good idea to conduct some sanity check to make sure that the labels are what you wanted to be included in the 2 label list. So I will print the 2 label list. I'm confirming that these are the 3 categorical columns that I want to apply one-hot encoding. And these are all the numeric columns that I want to apply range normalization. Now, once I prepared the encoder and the scalar, I'm ready to put together the column transformer. Making the column transformer is quite straightforward. I need only one line to make that. I use the make column transformer function. I provide two tuples. The first 2 tuple includes the one-hot encoder and the columns for the one-hot encoder. The second 2 tuple include the scalar and the columns for the scalar. And I assign to the transformer. So afterwards, I use the transformer to transform the train and test sets. And be very careful here. When you transform the train set, you want the transformer to get the necessary statistics from the xtrain only. For instance, for the min-max normalization, the transformer will get the minimum value and the maximum value of each of the variables to apply range standardization and store inside the transformer. So the fit transform method will first get those statistics and apply transformation by using those statistics. Afterwards, be sure to know that the output of the transformer is only a NumPy array. In order to be able to use the data frames methods, you want to make sure that you convert that to data frame. After the transformer is fitted and applied to the xtrain, it is now ready to transform the xtest dataset. And be very careful that you do not use the fit transform on the xtest because you do not want the transformer to recalibrate those statistics. You only want it to apply the transformation by using the statistics of the xtrain to transform xtest. Again, I convert that output into the data frame in order to use the data frame methods. Now let's run this. And let's quickly verify that the statistics are good after the transformation. So I will print basic statistics of all the columns in the xtrain dataset after being processed. Because the transformation is fitted to the xtrain dataset, all the min-max values will conform to the transformation output. Now the first few columns are actually the flag variables, so their min and max are always 0 and 1. For the rest of the variables, range normalizations are applied. Now let's move on to the test set, and there will be some interesting results. For the test set statistics, you see that for the first several columns, the min-max are still exactly 0 and 1. And that's because they are flag variables, and there are only two different kinds of values for the flag variables. But for the rest of the columns, the min sometimes break below the 0, but sometimes are not even 0. And for the max, sometimes the maximum value are as big as 2. And this is because transformer is not fitted to the test set. So that's why the test set is unseen data to the model. So these values sometimes will break the boundary, but that is fine. The model can be able to tolerate these small differences. So that's it for the transformer demonstration. I hope you enjoyed the video.